What if the future of computing wasn't silicon, but quantum particles? What if your laptop could solve in seconds what the world's fastest supercomputers couldn't crack in decades? In the next few minutes, we're unlocking quantum computing in a way even your grandma could understand. From bizarre quantum rules to how it could revolutionize medicine, AI, and global security. This is the next computing revolution. Classical computers, the ones powering your phone, your car, and even the rocket to Mars, run on bits. They're binary, 0 or 1, on or off. But quantum computers use qubits, and here's where it gets wild. A qubit can be 0 and 1 at the same time. Like flipping a coin and catching it in midair. It's both heads and tails until it lands. This is called superposition. And there's more. When qubits interact, they get entangled, meaning one affects the other, even from across the universe. That's quantum entanglement. It sounds like magic. But it's real, and it's going to change everything. Why should you care about qubits and entanglement? Because quantum computers could crack what today's machines can't even touch. Quantum computing could break modern cryptography, the backbone of the internet. It could simulate protein folding in seconds, speeding up cures for cancer or the next pandemic. It could optimize supply chains, simulate the universe, or predict financial markets with mind-bending precision. That's why Google, IBM, Intel, and nations like China, Germany, and the US are pouring billions into quantum R&D. The quantum race is like the space race, only this time, the winner owns the future of global tech. So how do they work? Quantum computers aren't built like regular PCs. They're cryogenically frozen, just above absolute zero, to keep qubits stable. They use quantum gates instead of logic gates, and every operation is so delicate, even a single stray photon can cause errors. This is why quantum error correction is one of the hardest challenges in the field. Some companies like D-Wave use a different method, quantum annealing, to tackle optimization problems. It's messy, experimental, but it's working. In 2019, Google made headlines claiming quantum supremacy. A quantum computer solved a problem in 200 seconds that would have taken the best classical computer 10,000 years. Pharmaceutical giants like Pfizer and Moderna are now exploring how quantum simulations can model drug behavior inside the body, before ever testing on humans. Companies like Airbus, Volkswagen, and DHL are testing quantum-powered logistics to save billions. We're already in the future, we just haven't scaled it yet. So, why don't you own a quantum computer yet? The biggest enemy? Decoherence, when a qubit loses its quantum state due to outside interference. Right now, most quantum computers can only keep states for microseconds, and that's just not enough. Add in error correction, noise, and costs in the millions per machine, and you'll understand why we're still early. It's not about making one quantum computer work. It's about making millions of stable qubits work together. So where's it all going? Top universities are already offering quantum computing courses. Platforms like Qiskit and IBM Quantum Lab let you run actual quantum code from your browser. The demand for quantum developers, theorists, and hardware engineers is skyrocketing. In 10 years, knowing quantum computing might be like knowing how to code in 2005. Early movers will lead. So what did we learn? Quantum computing isn't just science fiction. It's real and it's coming fast. From qubits and entanglement to solving problems that today's computers can't, this tech could change everything. Yes, there are challenges, but the breakthroughs happening right now are incredible. Want to explore more? Start with tools like IBM Quantum Lab or Qiskit. No PhD needed. If this opened your mind, hit like, comment your thoughts, and subscribe for more powerful tech explainers. The future is quantum. Are you ready?